mod of x minus 1 by 2 plus mod of x minus 3 by 2 equals to 1. Yes or no? Yes? Now understand this properly, how we are doing it. One method we already know, that is our general method. In most of the cases, we will apply that. But sometimes questions are given in such a form in which we can go for our shortcut method also. Can I write 1 equals to mod of x minus 1 by 2 minus x minus 3 by 2? Yes or no? It is basically what? Mod A plus mod B equals to mod of A minus B. Do we have this property? Normally, mod of A plus mod of B is always greater than equals to mod of A minus B. But if equality holds, then A and B must be of opposite sign. Yes or no? And here it is equality. Yes or no? That means A and B must be of opposite sign only when A dot B is lesser than equal to 0. Yes or no? Now, what is A? X minus 1 by 2. What is B? X minus 3 by 2 is lesser than equal to 0. X is element of 1 by 2 to 3 by 2. This is the answer we got yesterday. Yes or no? In one step, we have solved this. In fact, we don't really need to use pen. Yes or no? If we directly look at this question, and if we remember, oh, this property can be applied here, then you will directly multiply x minus 1 by 2 into x minus 3 by 2 in mind and say it is lesser than equal to 0. That means 1 by 2 to 3 by 2 answer mentally. Okay? Do you understand? Now, this is your special type of question. Only when this property is applied here, then only you can solve the question in this way. Now, let's say mod of x minus 1 by 2 plus mod of x minus 3 by 2 equal to what? 2x minus 1, 2 of x minus 1? Yes or no? It is actually equal to x minus 1 by 2 plus x minus 3 by 2. Yes or no? Now, mod of A plus mod of B equals to A plus B. A and B not same sign. We have talked about this property mod A plus mod B equals to mod of A plus B. That's what we have talked about. Yes or no? And in this case, A dot B is greater than equal to 0. Yes or no? But here what we are getting? Mod A plus mod B equals to A plus B. Yes or no? That means this mod is not making any difference. That means A must be positive and B must also be positive. Separately, they must be positive. What was the answer that we got? Did we solve this question yesterday? What was the answer that we were getting? That is the only answer? 3 by 2 to infinity only? Now, it is possible when A greater than equal to 0 and B greater than equal to 0. Yes or no? Do you understand? Mod of A plus mod of B equals to A plus B. This is possible only when A is a non-negative number, B is also non-negative number. That means x minus 1 by 2 is greater than equal to 0. X minus 3 by 2 is greater than equal to 0. From this, we are getting x greater than equals to 1 by 2. From this, we are getting x greater than equals to 3 by 2. If x is greater than equals to 3 by 2, then it automatically satisfies greater than equals to 1 by 2 or not. You got it? If we had in place of 2 times x minus 1, listen here, in place of 2x minus 1, if we had mod of 2x minus 1, then we would say a dot b must be greater than equal to 0. Yes or no? Then this property we would have applied here. Yes or no? Do you understand the concept? Why is that other student not coming? Answered? Okay. Done? Sure. Let's talk about another method. Can I solve this using any other method? Let's say if we talk about 2 times x minus 1. Listen up. Previous one was method number 2. Yesterday was method number 1. Okay. Let's say this whole expression is equals to f1x. Can I say this? Yes or no? The whole left hand side expression is, let's say, f1x. And whatever we have on the right hand side, let's say this is your f2x. Okay. It is your graphical method. Understand? f1x is nothing but mod of x minus 1 by 2 plus mod of x minus 3 by 2. Okay. Now, first of all, we will define the function without the modulus sign. That means we will take the intervals. Okay. So it is equal to, let's say x is element of 3 by 2 to infinity. Then both are positive. So I will get 2 times x minus 1 or not? I will get 2 times x minus 1. Yes or no? Let's say x is element of 1 by 2 to 3 by 2. That time this is positive, this is negative. x minus 1 by 2 minus x plus 3 by 2. We will get 1. And this is x is element of, let's say, minus infinity to 1 by 2. That time we will get minus 2 times x minus 1. Yes or no? Now what we need to do? We will draw its graph. Okay. Now when x is from 3 by 2 to infinity, let's say this is your 3 by 2. Then my graph is 2 times x minus 1. Okay. It is a straight line. This is what? Y equal to 2 times x minus 1 or not? It is your straight line with positive slope. Yes or no? Okay. Now it is a straight line and starting from 3 by 2 only it is valid. Yes or no? Now at 3 by 2, what is the value of this straight line? If I put, I want to know, see, at 3 by 2, there should be a particular point or not? And after that, it will be a straight line. Yes or no? So at 3 by 2, what is the value of this straight line? 3 by 2 minus 1 is 1. 3 by 2 minus 1 is 1 by 2. Into 2 is 1. Yes or no? So this value will be somewhere here. This is your plus 1. And after that, it will go like this. Okay. Now, 1 by 2 to 3 by 2. Let's say 1 by 2 is somewhere here. 1 by 2 to 3 by 2, the value is 1 only. So, okay. And when x is element of minus infinity to 1 by 2, then it is y equals to minus 2x minus 1. It is a straight line with negative slope. It will go something like this. Yes or no? Yes or no? At 1 by 2, what is the value? 1. Yes or no? At x equals to 1 by 2, the value is 1. Yes or no? That means this is point itself. Yes or no? When x equal to 0, y is equals to what? This line will be like this or not? Do you agree? Yes or no? Now, let's draw the graph of f2. f2 is 2 times x minus 1. Yes or no? Here also we had 2 times x minus 1, but it was valid only for 3 by 2 to infinity, and this is valid for all values of x. So it is, this is straight line only. Yes or no? Do we have another pen? Okay. This is your y equals to 2 times x minus 1. That means this is a graph of f2x. Yes or no? And this is a graph of f1x. Yes or no? And this is the only part where both the graphs are meeting. Yes or no? So if I want to find the solution are always those points at which your graphs are intersecting. Yes or no? Whenever you have this kind of equation, assume left hand side as one function, right hand side another function, and draw their graph. Wherever they are intersecting, that would be the solution. Yes or no? So if we see they are intersecting at all these values or not, at all these values they are intersecting. Yes or no? So my answer will be what? x is my answer will be 3 by 2 to infinity. At no other points, this line and this line, this graph is intersecting. We understand this? You can take any other graph also. Again, you will get the answer. Method number 3, just give it a heading, graphical method. Method number 2, just give it a heading, application of property. Method number 1, give it a heading, general method. These 3 heading must be there so that you understand what we are doing. All of you are understanding what we are doing here? You are also understanding? Got it? Any doubt? Okay. Quickly copy. Done? Should I take one more example of this graphical method? Okay, let's see. Let's take should I take little bit difficult? Can I take? Okay. Let's say mod of x minus 1 into x plus 1, let's say simple one, equals to, let's say 5. You can easily solve it. Yes or no? How do you solve it? X square minus 1 equals to plus minus 5. Can you do this? Yes or no? X square minus 1 equals to plus minus 5 or not? Okay. Now let's see. Let's say this is your f1x and this is your f2x. Okay. Now f1x is equal to x square minus 1 whenever x is element of minus infinity to minus 1 union 1 to infinity. How am I writing? Do you understand? f1x is mod of x minus 1 into x plus 1. Yes or no? I am writing it without mod of x minus 1 into x plus 1 is what? x square minus 1. So this is basically mod of x square minus 1 or not? I am directly writing mod of x square minus 1 as x square minus 1. That means x square minus 1 must be positive. So x plus 1 into x minus 1 is greater than equal to 0. Weaver method. X is element of minus infinity minus 1 union 1 to infinity. Yes or no? And minus of x square minus 1 when x is element of minus 1 to 1. Yes or no? Can we solve this part? You? Can we do this part or not? See, this is nothing but mod of x square minus 1 or not? Yes or no? Now, we open mod with the same sign whenever x square minus 1 is positive. Whenever x square minus 1 is greater than equal to 0, then only we can write like this. Yes or no? That means x minus 1 into x plus 1 greater than equal to 0. Weaver method. Can you solve? If you solve, then you will get this condition. Same, this is minus of x square minus 1 whenever x square minus 1 is negative. When x square minus 1 is negative, that means x plus 1 into x minus 1 is negative. Can we apply Weaver method here? Yes or no? I'm not going into calculative part. Okay, calculation you guys can do. We have already discussed all these things. Yes or no? What we are discussing is the method itself, not the calculation. And f2x is nothing but 5. So can I say y equal to 5? Now let's see its graph. And in any way, we have modulus, so we can draw its graph very easily. Y equal to x square minus 1. It is an equation of parabola, upward opening parabola. Yes or no? It is an equation of upward opening parabola or not? See, if I write this y equal to x square minus 1, then I can write it y plus 1 equal to x minus 0 whole square or not? Yes or no? So what is the vertex? 0 comma minus 1. So its vertex is coming on the y-axis 0 comma minus 1. Yes or no? And it will be like this. Yes or no? Do you understand? This is your 0 comma minus 1. And what is this point? This point is, if you see, when y is becoming 0, y is becoming 0, that means x equals to x square equal to 1, x equals to plus minus 1. This is your plus 1. This is your minus 1. Yes or no? If you see, if y is 0, okay, then x square equal to 1 or not? So x equal to plus minus 1. You understand this? Now, listen. This is valid only when minus infinity to minus 1 union 1 to infinity. That means 1 to infinity, it is valid for greater than 1 or lesser than minus 1. It is not valid when your graph is below the x-axis. Yes or no? But do we know? I think we have already talked about it. Whenever we have modulus, we flip the curve which is below the x-axis. Yes or no? So this part, only this part is below the x-axis. So we will flip it over. Yes or no? We will flip it over and 0 comma minus 1 will reach to 0 comma 1. Yes or no? This will be your actual curve. Yes or no? Is it clear? Now f2x equal to 5. That means y equals to 5. Constant. Y equal to 5. It is basically a straight line but constant. So this is y equal to This is y equal to 1. So plus 5 will be somewhere here. Yes or no? So this is one of the solution. This is second solution. Do you understand this? Do you understand this? So how many solutions we have? We have two solutions. So understand this. Graphical method gives you the number of solutions. It is difficult to get the value of the solution itself from the graph. Yes or no? Until and unless we are making the graph using all the scales, all the measurement, we will not get the value of x just by looking at the graph. Okay. In the previous case, we got lucky. Yes or no? In the previous case, we got lucky. So we were able to find. In some of the question, you will be able to find the values of x based on the graph itself, from the graph itself. But in majority of the cases, you will find only the number of solutions, not the value of the solutions. And in so many questions, you will get question like this. This equation is satisfied for how many values of x? Yes or no? Do you get this question? That time you don't really need exact value. All you need is what? How many values? How many values? From this, you can even tell the solution will lie either in minus infinity to minus 1 interval or 1 to infinity interval. Yes or no? Only this branch and this branch is getting intersected. Yes or no? So this value is greater than 1 or not, and this value is lesser than minus 1. Yes or no? Now understand how graphical method gives us more information. Okay. Sometimes questions ask, they will not give the value of 5. They will not give you the value of f of 2x. They will give you some constant, let's say a. Understand this? Have you understood this part? Let's say instead of 5, I give, let's say 1 by 2. Let's say it is 1 by 2. Then 1 by 2 will be somewhere here. Then you will have 1, 2, 3, and 4 solution. Yes or no? You understand? Now, sometimes what happens? They will give you this equals to A, and they will give you option. If A is greater than 1, then equation has two solutions. Understand this? First option, let's say, if A is greater than 1, that means your line will be above this curve or not? Above this middle curve. So it will intersect only at 2 points. Yes or no? Let's say they give the other option. If your A is 0 to 1, then you will have 4 solutions. Yes, obviously right. Just by looking at the graph, we can infer. If A is negative, then there is no solution. We don't even have to look for graph in that case. If A is negative, left hand side is positive or not? Modulus. Negative equals to positive, not possible. You understand this? Now copy this and write it in your own words, whatever we have discussed. Did you understand everything? Okay, attention. Let's say if I take a equals to exact 1, yes or no? That means my straight line will pass through this point. So two solutions will be here and one solution will be here. So three solutions. Let's say a equal to 0. That means this x-axis, yes or no? This is my x-axis. If a equal to 0, then it will intersect at this point and this point only. So two solutions. Chalo, quickly. Understand it like a bar. Okay? Understand it like a bar, and you are moving this bar on the y-axis. Okay? Now you are getting the feeling. In mathematics, it is little difficult to get the feeling, but this way, if you understand, you will start having a feeling, and whenever you have a feeling, question becomes very easy. If you follow whatever I'm teaching you, each and every subtopic of your mathematics, you will start having feelings. You will start having intuition in those questions. Should I rub this off? So we have actually, this is all the postmortem. There is nothing more to this question. Yes or no? So you understand, if any question comes, you have three possibilities. First is your method number one is your general method. That method is always applicable. Okay. Method number two is applicable only when it is satisfying your property. Method number three, it will give you not the exact value, but number of values. Clear? So it depends upon the question, what the question is asking, the nature of the question. In the question, let's say if you have f2 equals to a, then obviously graphical method he is basing his question on. Yes or no? Should I rub this off completely? Now let's come to logarithmic inequalities. These questions, the question based on not logarithmic inequalities, sorry, modulus inequalities, absolute value inequalities. Now simple questions, we have discussed three methods. I will give you DPP on it. Solve questions, we'll discuss. There is no other concept left except to practice. Okay. Now let's come to Inequalities involving modulus functions. First of all, understand what is the significance of mod x, what is it is representing. Okay, understand. Let's say if I take x equals to, give me any value, -5. So this is, let's say, x equals to -5. Let's say I take x equals to +5 also. Okay, and in between, obviously, there is origin, that is 0. Yes or no? Now, what is the output of modulus x in this case? +5. Can I say it is the distance of x equals to 5 and x equals to -5 from origin? Can I say this? It is the distance of x equals to +5 and x equals to -5 from origin. Distance is always positive or not? It is always positive. So mod x is nothing but, now you will be able to correlate it. Mod x is nothing but mod of x minus 0 vector form and its modulus. It is not the same modulus, but it is vector form or not? Final minus initial vector, something like this. So it is basically representing distance of x from origin on the number line. On the number line. Do we understand this? Very, very easy. Yes or no? Similarly, if I say mod of x minus 2, then it is nothing but distance of x from x equals to 2 on number line. Yes or no? Do we understand this? Now, based on this concept, we will look at how involving inequalities involving modulus are solved. Okay, I'll just start it. Let's say first case, modulus of x is greater than equals to a, let's say. Or let's say first case, I take modulus of x lesser than equals to a, where a is greater than 0. Okay, obviously a has to be positive or not, because modulus x is positive. So we are assuming a is positive. Okay, now what it is saying, the distance of any point, any general point x from origin is lesser than a unit. Let's say this is your number line, this is your origin. A will be some value or not? A is equals to, let's say, 2 or 5 or 3. Yes or no? So let's say this is your A. Now mod of x, what do we mean by that? The distance of this x is variable here now. Yes or no? X can vary. We have to choose x in such a way that its distance from origin is lesser than a unit. Yes or no? So if I choose x somewhere here, it is acceptable because a unit is this much. Yes or no? So I can definitely choose x here. I can choose x here also, here also, here also. So this is the band of my values of x. Yes or no? X can lie here or not? Yes or no? If I choose my x in this band, then it is always closer to origin. Yes or no? You understand? Now, if I take values of x after a, then its distance from the origin will be greater than a unit or not. So that is not acceptable. But again, what we are talking about, distance. So if we can take the band here, then we can take the band here also. Yes or no? Let's say if I take value of x somewhere here, then obviously this is mod x and it is lesser than a or not. Yes or no? Do you understand? Yes or no? Again, this much also I can take till minus a I can consider because distance is positive. So the value of x should lie in this band. Yes or no? So mod x is lesser than a, lesser than equals to a is basically equivalent to saying x is element of minus a to a. X is lesser than equals to a, greater than equals to minus a. X can take any value from minus a to plus a if mod x is lesser than equals to a. Do we understand this? Do we understand? Straightforward. Now, the same thing you have to prove for, let's say this is your second number. Mod x is greater than equals to a. Mod x is lesser than equals to b and greater than equals to a. That is the crux of what?